Well, now we're going to talk about lines just a little bit. Most of this should be review, just like a lot of this other chapter stuff, but we'll see. And I know some of you haven't done some of this stuff for a long time. Remember, slope is equal to rise over run, also known as a vertical over the horizontal. You won't really need this until a later chapter, but it's also what's called the rate of change. Lastly, slope is given by the formula y2 minus y1 over x2 minus x1. So, as an example, let's say I'd ask you to find the slope between the points 2, 3 and negative 1, 5. If you wanted to, the first thing you could do is label xy and xy. Now, literally, you're just going to subtract the y's on top and the x's on the bottom. The way that I always try to remember this is that y's rhymes with rise. And then, boom. Just make sure that when you subtract, you gotta go in the same direction. That's why I like to draw those arrows there. So I got 5 minus 3 on top because the y's rhyme with rise. And on the bottom, I got a negative 1 minus 2. And you get 2 over negative 3. And the easiest thing to do, if there's just one negative there, just put it in front. Just as a note, if you would have done it the other way, 3 minus 5 and 2 minus negative 1, you'd have ended up with negative 2/3, which is negative 2/3. And you get the same answer. So it doesn't really matter which way you subtract, you just gotta make sure you do it in the same direction when you do it. This is what's called the slope man, and what it's saying basically is if it goes down and to the right, you got a negative slope there. If it goes up and to the right, you got a positive slope. If it is a vertical line, it is a U, which stands for undefined, and if it's a horizontal line, it has a 0 slope. So, once again, vertical is undefined or no, horizontal is a 0 slope. Let's say I just gave you a line and I was like, hey, let's find the slope of that line. What you're going to do is you're just going to count rise over run. You've always got to count it from the leftmost dot though. Always from the left. You read left to right, so find slope from left to right. So I count up 3 over 2. So its slope, which if you don't remember is always denoted by the letter M, is 3 over 2. That's it. Another note, if you have a vertical line, its formula is always just going to be x equals whatever it's at. Because the x stays the same, right? It goes up at x equals 2, let's say, and it's never going left or right, so it's always at 2. The only thing it's changing is the y. Conversely, if you have a horizontal line, its formula is going to be y equals something, because the y never changes. It stays the same the whole time. Now, hopefully this is the one formula that you remember the best, which is y equals mx plus b. M stands for the slope, and b stands for the y-intercept, which is where it crosses the y-axis. So, if I give you the formula y equals negative 2/3 x plus 4, what you got to know, that's what we used to call the lonely number. It's all by itself. It has no x's. He's been lonely, or she or they has been lonely its whole life. That's the y-intercept. So that's where you put your first dot at positive 4. Now, you use the slope just to count down to over 3. Draw your line and you're done. What I forgot to say, and what I put right here, is that this is what's called slope-intercept form, because M is slope, B is y-intercept. Now, there's another form that's called point-slope form. You can honestly get by without knowing this other than doing the problems on WebAssign, but sometimes it's handy. And it's y minus y1 equals M x minus x1, where m, once again, is the slope, and x1, y1 is any point on that line. So let's say I want you to graph y plus 1 equals 2, x minus 2. Basically, I always break this down in just a couple steps. The slope is 2, and don't forget that 2 is really saying 2 over 1, and then the point is 2 comma negative 1, and I wrote opposite there in real big letters because since this is a minus here and a minus here, you're always taking the opposites of what's there. Since that's a plus, it becomes a minus, and since this was a minus, it became a plus. Now all you got to do is graph that point 2 negative 1, which was here, and then use that slope up 2 over 1 and draw your line. So graph the point, boom, use the slope to find the other point. Now there's some times where they're going to make you do a little bit of math now, and basically each of these questions is going to add one extra step each time, and then it goes back to what it was. So this is basically the simplest one you can have. If I give you the slope and I give you the y-intercept, you just got to write y equals slope x, y-intercept, and you're done. Now the next one, I can give you the slope, and then I can give you a point that it goes through. And you've got to do a little bit of algebra now. We know that y equals mx plus b, and we know that points are labeled as x and y. So now we know y, we know the slope, which is m, and we know the x, which goes here. The only thing we don't know is what b is. So we just plug in everything we know, and then we're going to solve for b. Negative 3 equals 3 times 1 plus b, because negative 3 is the y, m is the slope, which is 3, and the x is 1. Basically now 3 times 1 is 3. Subtract 3 from both sides, you get negative 6 equals b. Now you just rewrite your equation. Y equals slope, which we know is 3, minus 6, which we just found was the y-intercept. And if you see, we basically just got the same equation that we started with. Now, there's an alternate way you could have done this, which was to use point-slope form, because literally in this formula, in that problem, I gave you a slope, and then I gave you a point. So we know y minus y1 equals mx minus x1. In every single point-slope problem, they're always going to have a y and an x like that. All you got to do is know what goes in the parentheses and what the slope is. I don't know the difference between these two things. Boom. All we got to do is plug in that point. We always have a minus every single time, so y minus negative 3, because that's what y was, equals 3, because the slope was 3, and then minus 1, because the 1 was there. Two negatives turn into a positive. So our answer is y plus 3 equals 3x minus 1. And you could be done right there. That is legitimate equation of a line. Now, I just want to note that if you wanted to double check your work, you could write it as y plus 3 equals 3x minus 1. You can then distribute that right side. 3 times x is 3x. 3 times negative 1 is negative 3. And then you could solve for y by subtracting 3 from both sides, and we get y equals 3x minus 6, which is the exact same thing we got here. So what that is proven is that these two formulas, these two answers, are actually the exact same thing, just written differently. Now, the most difficult question you could have like this is if I gave you just 2 points, and then you had to find the equation of a line. Step 1, find the slope first. xy, xy. Oh, and if you didn't notice, I wrote it backwards the first time. I had 0, 2, but I really wanted 2, 0, so I changed it before we started this question, right here. So I just plugged it into the formula. I subtracted the opposite way I did last time. 0 minus negative 3 is positive 3. 2 minus 1 is 1. 3 divided by 1 is 3. Now, you can use either one of these 2 points, and you're just going to solve it either this way or this way. So like I said, basically, each of these things just adds one more step. This one you had to find the slope, and then you do these things. On this one, you had to plug it in and find the y-intercept before you could plug it in like this one. So, real quick, I just did this right now, and I chose the point 2, 0, even though I could have used 1, -3. Doing the math, you get y equals 3x minus 6, which is the same answer that we had before. If I would have done it the other way, you just plug it in. Y minus 0 equals 3x minus 2. And you're done. Now, last thing we got to learn is about parallel lines and perpendicular lines. Parallel lines, remember, boom, boom, they got the same slope. Because if this goes up 2 over 5, this one has to go up 2 over 5 because they're always the same distance apart every single time. Perpendicular lines, if you remember, are lines across at 90-degree angles like this. 90 degrees right there. They have opposite slopes, which are negative reciprocals of each other, or what we used to call the flip and change sign, or sometimes the flip and switch. Boom. So, basically, I could ask you, well, before I forget, this is the symbol for parallel. If I don't want to write it out, you just draw basically an 11. And the symbol for perpendicular is basically an upside down capital T. So find the equation parallel and perpendicular to y equals -1/2 x plus 11 that goes through the point 4, 1. This is 2 separate problems now. You're going to do one for parallel, and what you got to know is that the slope is -1/2 because it's the same as what this one is, and then it goes through the point 4, 1. Once you've written this down, it goes back to this type of problem that we've already done. So, solve like above. I'm going to use the y equals mx plus b form. We know y is 1 because it's the second point, equals -1/2 because that's what slope was, 4 because that's what x was, plus b. -1/2 times 4 is -2, so I'm going to add 2 to both sides and you get b equals 3. And then you just plug it into your y equals mx plus b formula, and you get y equals -1/2 x plus 3. Perpendicular, man, I don't know why the quality of these pictures gets so bad. We know m is 2, because we got to flip and change that slope right there. So it was -1 over 2. You flip it, it turns into 2 over 1, and you change it from negative to positive. So it's just positive 2 over 1, which just equals to 2. And now you got a slope of 2, and it still goes through that point, 4, 1. Now if you just wanted to use point slope formula, you're literally just going to plug it in. Y, opposite of 1 is -1, equals 2, because that's the slope. X, opposite of positive 4 is -4, and you are done.